All right. Hey, everyone. Welcome to the SIP Debug Overview webinar. We're going to give it another couple minutes just to let more people join before we get started. We'll probably start at 12:05. All right. I think we can get started. Jerry, if you want to take it
All
away.
right, sure. We'll talk a little SIP today, and it's definitely more of a primer, very high level overview. SIP is a very large subject that could be, years worth of training essentially, but the intent here is to try to get people to a point where they can find some use of it, know the real basics of how to utilize it for debugging on our system. So we'll talk a little bit about Waldek's architecture so that we can understand where we are pulling a SIP trace from as an example, what you should expect to see. We'll talk some about just kind of general call flows, SIP in general. We'll talk about things like TLS and what secure SIP means relative to what you would expect to see in a PCAP. And some other kind of typical call flows in general. So from an architecture perspective, the box here basically is representing our PBX, if you will, and it runs lots of services inside the PBX. So SIP trunks come in via, a SIP cloud, the internet, if you will. Devices hang off of that SIP cloud or the internet, if you will. And they communicate to and from the SIP proxy. The SIP proxy is sometimes we'll refer to it as Camilio. That's the actual process name, if you will, or the piece of software. It does nothing more than proxy information to and from devices. That's its sole purpose in life, essentially. Outside of that, it doesn't really decide on where to route calls and things like that. That's done by the PBX engine or call weaver. So it's important to recognize that there's two components inside of a PBX that talk SIP amongst themselves to process a call flow. The result of that is that you would see SIP signaling to and from those two processes on a bit of an unusual looking IP address, which is the loopback IP address of the PBX itself. So it's a 127.0.0.1 address. So in most PCAPs, in all PCAPs really that you take from the PBX, you're going to see traffic to and from these two processes on that loopback IP address. So things that you would expect to see in a normal situation when you run a trace on the PBX. You would see SIP and RTP to and from a carrier, assuming that carrier isn't set up in some way to use TLS. You would see to and from any gateways or phones, devices, things like that, that are on net with the PBX. And you would see only SIP from in the case that it's a cloud PBX and you're off net. So in all cases, though, one thing to point out here too is that you're only going to see SIP to and from the two processes that I discussed on that loopback interface, because effectively there is no RTP being sent between the two. And we'll talk a little bit more about RTP, but from a very high level perspective, SIP does the signaling to set up a connection between two SIP devices, and RTP is the media stream that's used to actually send sound, if you will. What you're not going to see is things like SIP or RTP to and from remote devices like phones and such, and or SIP trunks using TLS. And why this is because devices that are off net from the PBX, they use TLS by default. So you don't set it as TLS per se, but by default, when you provision a remote device off of a cloud PBX, it uses TLS. TLS is encrypted, so it's not going to show up in a SIP trace as standard SIP signaling. All right. Similarly, there is RTP and the concept of this voice that is directly passed from two devices in the network. So we call it direct RTP. And what happens here is you set up a call, and when the negotiation is done between the two endpoints for this call, example, the the A leg phone, if you will, for a call into the PBX, and the B leg call, if you will, out to a device on the PBX. Those two things could be remote from the cloud PBX. They are in fact remote from the cloud PBX. And what you don't really want to do is to send this media, this RTP stream, all the way from the device up to the PBX and all the way back down. It's more efficient and much better bandwidth utilization if you send direct RTP, meaning phone A sends its RTP stream to phone B directly over the local network. So in the case where two devices are on net with each other, but off net relative to the PBX, direct RTP is applied, and therefore you would not see RTP at the PBX. So that's an important factor also from architectural perspective in terms of what you would see here. So again, any leg of a call that is remote would by nature use TLS, and you're not going to then see this open SIP kind of communication. But you will always see the SIP signaling at least between the two pieces of software on the PBX, being Camellia or the SIP proxy, and CallWeaver or the PBX engine. So what sorts of things can you use to, or can you debug using a PCAP? Well, many things. For sake of today's discussion, we'll talk about things that are primarily signaling related. So some attempt to route a call that fails. Who hung up a call that ultimately did route and then was later hung up on. What the caller ID information is. What digits you're passing to a SIP trunk, as an example, or what digits a SIP trunk is passing into you. These are all things that you can see. And then there's some additional interesting headers like alert info and contact headers and things like this that you can see inside of it that tell you unique things about a call. So at a super high level, are there any initial questions?
Doesn't appear to be any questions yet.
Okay, we'll just keep flowing. So let's talk about a general, real high level SIP call flow. So in a call flow, what you're going to see is you're going to see, point A, which could be a phone, a PBX, a SIP trunk, whatever, is going to signal to point B. They're going to ultimately decide how to negotiate that call and where to send media to, and then ultimately they'll hang the call up. So an invite is the initial part of a SIP call flow. So I send you an invite, you send me back some information that says, okay, I'm trying to route it. Okay, now I have found a route and I'm ringing. Sometimes there's even an additional, like a in progress 183 as an example, but nonetheless, you're giving me status about what it is that you're doing with my original request. And then ultimately, when you find a device that answers that call, you would send me back a 200 OK, which says that it's answered, and I acknowledge that through an ACK. At this point, then typically you would start to pass media or RTP to and from the negotiated points that were identified in what is called SDP within a SIP call flow. Once we're done talking, either you or I send a buy, and ultimately after the buy, the other party acknowledges that with a 200 OK. So regardless of what system you're using, if it's leveraging SIP, this is the sort of basic call flow that you're going to see from a SIP signaling perspective. So in our WMS, there is a way to generate a trace. I would imagine that most everybody has seen this. You can come here, just start it, go ahead and download the trace file, and ultimately have that for inspection. So let's just go ahead and do that once, just so we can kind of get a feel for what it looks like. Everybody can kind of remember. So under settings, tools and utilities, generate trace. We're going to start a trace here. And ultimately, I'll send a call. And I'm just going to send it to some kind of nonsense digits. And the call failed. Okay. So I can come back now. I can stop that trace. I can pull the trace down and I can take a look at it. So I've clicked on the link, downloaded it, and now I can open that up. Now, what this opens up with is a tool called Wireshark. I presume that most everybody has seen this as well. I'm not going to go into a bunch of depth about how to use Wireshark really. that, there's a lot to learn on that front. But I am going to show one super simple option that everybody should know. And that is under the telephony menu, there is a VoIP calls option. If you select VoIP calls, Wireshark will essentially find all of the SIP signaling in the system that has, that is call related, an actual call, and then ultimately what results from that call. So here's the test call I made while we started the trace, and now I can actually flow that sequence, meaning I see the invite, the trying, and in this case, a decline, 603 declined, because I sent nonsense digits, right? Now, something to remember from earlier is I mentioned this 127.001 address. This is that address. This is the internal address in the PBX that's used for CallWeaver and Camilio to talk to one another. So it looks strange because it looks like this machine is talking to itself. And in fact, it really is. It's talking between two processes amongst itself. An interesting point is that these little arrows tell you where the communication is going to and from. So in this case, this is a request being sent from 5060, port 5060 that is, to 6050. That means it's going from Camilio to CallWeaver. And then vice versa. You can see this one goes the other way. That's CallWeaver replying back with a trying, and ultimately CallWeaver replying back with a declined, and that being ACT. Okay, so that's a call flow. I can then take a look at content of the PCAP by clicking on one of these and going back to this original window and opening up the SIP portion and inspecting the actual content of my message. Okay, we'll talk a little bit more about this in a little bit. So that's the basis of it in terms of being able to just grab a PCAP and start to inspect it. So let's start to talk a little bit about the headers, and we'll look at some more traces in a little while and see them in real time, if you will, within Wireshark. But there are many headers inside of SIP, but the basic headers to be aware of inside of a SIP invite are these ones: the request line, the to and from, the via, contact, call ID, and SDP. So what these things are: the request line basically says, where do I want you to route this call? The to is also that, but it stays the same throughout the duration of a call, and it also includes some target user sort of information. The from is where the call is coming from, a SIP URI of who's sending it, essentially, something like that. And then a via header. A via header is about a route. How is a SIP invite routed? So it's essentially the return address, if you want to think of it that way. So maybe a SIP invite starts all the way back on somebody else's PBX, and then that PBX sends the invite out of SIP trunk to a carrier, and then that carrier sends it into my SIP trunk to my PBX. So there's all these steps along the way that have been hit, and for each of these steps or points that the call routed through, you end up with this via header attached. So essentially, each individual point knows where to send it back to. So that's the idea of a via header, extremely important header relative to routing in the SIP world. The contact, not connect. So a bit of a typo there, but contact header is it basically says what's the most direct route. So if I can get to the contact header directly, it's on net to me, if you will, then this is where the contact header comes into play. A call ID is an ID that is unique for this call throughout its life. So if I start to send information back and forth, I may be processing many calls at the same time. In some way, we need to be able to understand which call we're talking about, and that's done through the call ID. And then the SDP portion of SIP headers is all about media and this media negotiation and ultimately RTP. Okay, any questions on that so far?
All right, we have one question. On a hardware PBX, does the PCAP include the physical interfaces or just the loopback?
It would include the physical interfaces. So you would see what's coming and going from to or from a phone, if you will. I think that's probably the question, and you would in fact see that. So you would see, something that is the IP address of the interface communicating with the um, phone itself, and you would see the loopback 127.0.1 interface. All right.
Can
So
trace, oh, sorry, one
yeah,
more.
go ahead. Sure.
Can traces only be done real time?
This is a good question. So the answer is no, but traces can only be done in real time from the UI. Uh, so to do a trace that runs for some long period of time, you can do that from the Linux command line prompt with a utility called TCP dump. And TCP dump actually is exactly what's being used when you start a real-time trace through the UI, but all of the options aren't exposed there. I guess honestly, I think you maybe can put enough options there at the UI to even start it from there. But the truth is that if you want to do it for a long period of time, you would ultimately want to do it at the Linux command prompt so that you can run that in the background and that process won't die off or anything like that. So we can send as a follow-up to this the actual, some sets of commands that you can use at that level to be able to run a, kind of an ongoing trace.
All right. Now we're ready to move on. Thank you.
All right. So some other SIP call flows, right? So we talked about what a basic invite looks like. We'll look at some more for that. But there's also the idea of authentication. So I might have to register to my SIP trunk provider. A device surely has to register to the PBX that it wants to communicate with, things like that, right? So this flow on the left shows a standard sort of registration and the processing that occurs there. So what happens is essentially I send you a registration, you say, hey, you're not authorized to be here. Along in that unauthorized, I send some additional information, security related information. I reformulate then the register with that to include some additional security based information. I resend that registration with that, and then ultimately you get a 200 OK. The blue, for sake of this conversation, will ignore that. But so a register, a 401, and then followed by a registration again with a 200 OK saying that it's accepted. That's a standard registration flow. Similarly, you can see authentication related things occur during a call. So the flow that's shown on the right here is one where somebody has sent me an invite. I sent a trying like usual. And if you recall previously, then I would see some sort of 1.8, like 180 or 183, something like that, and then a 200. But in this case, what I see is a 407, says I'm unauthorized. It sent me some security seed information. I send back an invite that includes that sort of information, or a password essentially, if you will, that's created on the fly. And then the call proceeds as normal from there. So once it's challenged me, I send back what it needs, and then he says, okay, I'm 183, I'm progressing the call. Ultimately, I've answered the call. And then just like before, I get an act for the answer. Ultimately, somebody sends a buy, the 200 okay for the buy. So these are other types of call flows that would be, very basic types of call flows that you might run across. Another one to talk about is subscribe notify. So in the world of SIP, you want to be able to send information about other devices. So the simple one here is something like message waiting indicators, presence, things along those lines. So if I want to gain presence information as, say, user 100, and I want to see what user 200 is doing, then I subscribe for the events associated with 200. When I make that subscription, I get a 200 OK, and then every event that occurs that changes the presence state of 200, I get a notify. On each notify, I send back a 200 OK. So ultimately, I say, hey, proxy, I want this information. The proxy says, okay, got it. It keeps track of who needs information about who, and it sends out notifies for every time that some sort of state change occurs. Interestingly, CallWeaver is more often than not the one that knows that something occurred. So what CallWeaver does is it sends a publish. So CallWeaver says publishes the state of user 200 in my example, and then SIP proxy or Camilio takes care of informing or sending an event to every end device that needs or has subscribed for that information. So CallWeaver sends it once to Camilio. Camilio takes care of sending it once to every endpoint that requires the information. So there's some additional information in a PCAP. We'll maybe talk about these lightly here. There's an alert info header that's interesting. We use it for basically the ability to send the phone a ringtone to use. There's things like this call information field that send things like this answer after flag for things like paging via invite or intercom. So I just mentioned these because I want you to be aware that there are kind of feature related information inside some of the headers in a SIP invite. So as you dig into the SIP protocol a little bit more, start digging a little bit deeper on call flows, you'll notice some of these headers like this. So let's take a little bit of a closer look at some PCAPs that I've just created previously. Okay, so here's one that is about as simple as it gets. I've got this PCAP file sitting over here, and I'll open it, and it is an echo test. Okay, so I open the PCAP, I go to telephony, VoIP calls, and this is the only call in this PCAP. Otherwise, there'd be a whole bunch of them, but this is an echo test. So I've selected the one I want. I go ahead and flow that, and now I can see this SIP signaling. It also shows RTP. This RTP is often sent a piece of RTP kind of like before the actual RTP or media stream starts for the purposes of, punching a hole, if you will, um, in routed networks, right? Get a route or a path opened so that immediately when the real call is answered, then you get some media, right? So sometimes, oh, actually, this one maybe is even on net and it's um, actual media, but nonetheless, this sort of RTP flow is what you'd see in many cases. And again, kind of topic for another day. But so let's just go through it. All right. So I have an invite, and that invite, I can see all of the SIP header information associated with the invite over here. Okay. This message body, this is where you're going to see the SDP that we've been talking about. This is all about media, right? What can I accept from a media perspective? What do, and then the other guy sends me what he expects and things like that. That's what this SDP is all about, so that we can negotiate the RTP. But let's focus on the SIP for now. So here's these headers that I was talking about, right? So you have a request line. Where do I need this call to be sent? Well, I want to send it to 76, which happens to be the echo test. And this is on the loopback interface, so it's this 127.001 address. The extra headers that I talked about are these via headers, right? How are we going to route this SIP traffic around within the network? Okay. Where it's coming, where it's addressed to, where it's addressed from, the unique ID that we talked about previously, right? And by the way, some of this negotiation of authentication that I mentioned before with kind of security related things, that's what this is what this proxy authentication is all about, or authorization field rather, is all about. So it has to do with authorization of the call. The contact header, which we mentioned as well. And then in this case, I have some additional custom headers that we use for all kinds of information. Like this one, as an example, says deny direct RTP, don't allow it. So again, this is kind of like one of these additional headers that is more feature based in general. So that's a simple echo test PCAP. So let's take a look at now something a little bit more interesting, an inbound call, so that we can see multiple legs of a call. So again, I open it, VoIP calls, and now I see something more interesting. I have what appears to be two calls. In reality, these two calls are in fact related to one another. One of these two is related to the A leg, the caller from the outside world calling into my SIP trunk on this phone number, 380 blah, blah, blah. Okay. And then this leg of the call is from that caller 2402. So it's the B leg side. So the first one is the A leg from the outside world. The second one is the leg going out to the actual PBX user's phone. So one thing interesting about Wireshark is I can select multiple of these and then flow the sequence, and it kind of color codes what is going on in terms of which leg is which. So the green is the A leg, and the, I don't know, maybe burnt orange is the B leg for the call out to the phone. So in this case, I see that the SIP trunk provider must be on a 208.85.62.103 address. The 172 address is the public IP address of the cloud PBX. Okay. And the 127 is, as we discussed before, that loop around trunk. So the first question I ask is, why don't I see the signaling or the IP address of the phone? Well, the answer to that is because that is TLS. It's a remote phone off of a cloud PBX. Therefore, it's secured, it's under TLS, and I don't see the open SIP communication to it. Now, what I will see is the invite that is directed toward it on the loopback. Okay, so here's an invite. The first line here comes in from the SIP carrier, and our proxy says, okay, I'm trying, I'm giving it a try, right? Then inside of the loopback, the proxy sends that invite forward to CallWeaver. That's what we're seeing here. CallWeaver says, okay, I'll give that a try. And then you get this invite. So now CallWeaver has to figure out where to route it. It says, oh, it belongs down there on user, whatever. I'll try to invite that user. Okay, so it makes a routing decision and it forwards the invite yet again to the phone. That's what this leg here is showing. Hopefully you can see me selecting one to the other okay there. But this is the CallWeaver sending an invite back to Camilio, but this is an invite that's intended to go to the phone. Okay, so this, it looks complicated, but just to review one more time, the invite comes in from the carrier to the proxy, right? Then the proxy forwards that invite to CallWeaver internally. Then CallWeaver determines, oh, that call needs to go to this specific user, so it sends an invite back to Camilio, the SIP proxy, to get the call out to the phone. Okay, now if we were on a PBX, in this case, like a hardware PBX where my phone was on net, then you would see you would see that invite again get forwarded off to the IP address of the phone. Okay, so in each of these legs, if you think about our very basic SIP call flow, it is really the same. Okay, so it's an invite, it's a trying, it's a ringing back to the SIP trunk provider. Right now, I'm discussing only the SIP signaling to and from the SIP trunk provider. So it's that A leg, it's what's in green here, right? So it's invite, 100, 180, 200 OK. Ultimately, we are talking, we acknowledge the 200 OK, and at some point down here, we get the buy and a 200 OK associated with the a buy. So if you think back to the really simple looking SIP call flow, that is in fact it for the A leg. Invite, trying, 180, 200 OK to answer it. We're now answered. We send ultimately send a buy, 200 OK to tear the call down. And it's easier to see when it's going from one IP address to another, visually on Wireshark, but it's exactly the same if you look at what's going on 127.001. It's an invite, 100 trying, a 180 ringing, and then for this leg, ultimately a 200 OK, et cetera, et cetera. So it's exactly the same call flow as it was before. But and again, to reiterate something I said earlier, you can see this internal traffic across the two different ports. So you can always tell, is it Camilio or the proxy sending this invite to CallWeaver, like in this case, because it's 50-60 to 60-50, or is it CallWeaver sending the invite back to Camilio, which is 60-50 to 50-60. All right. Are we still on? Ah, okay, I'm going to continue. It seems that maybe we've gotten disconnected, but I'm not sure, so I'm going to just check
Oh,
with.
no, we're
Oh,
still here. Sorry.
okay, no problem. All right, so I'll continue. So that was an inbound call. Let's now take a look at an outbound call. Very similar again. We're gonna see multiple legs. We can inspect only one of them or both of them, and we can see all of the legs of the calls to include the internal communication. Right? So again, telephony VoIP calls. This time, let's just select one leg of the call at a time and see, what that looks like. So in this case, I've got uh, only the 127 address. And so this is a call coming from 402. I can see that here, to a 614 number. Okay. Well, why don't I see the phone sending an invite? Again, because it's TLS, it's a remote phone off of a cloud PBX. So I don't see that leg. The first reference that I see to this call is the proxy forwarding that invite over to CallWeaver. So here's my invite, my initial invite. Then again, it's a 100 trying, 183, some RTP for media, a 200 OK that says it's answered, an ACK for the 200 OK, a buy, and then a 200 OK to say, okay, I get it, I hung up. So this flow is what CallWeaver and Camilio or SIP proxy are discussing amongst themselves internal to the PBX. This next leg of the call, if you will, is the leg that actually went out to the carrier. So we'll inspect this one separately again. There's some information being discussed, if you will, between the two processes in the PBX here. But the most interesting bit to me now is to see what I'm sending and receiving and getting back from the carrier. So again, I've got, an invite, a trying, and in this case, I see this 401 unauthorized, right? So this is one of these cases where they've asked me for some additional level of authentication, if you will. I acknowledge that. I send them a new invite with some additional information in it. And then the call flow proceeds as always. 100 trying, 183, some RTP, ultimately a 200 OK to answer, acknowledge it, a buy, a 200 OK for the buy. So every leg is, effectively the same simple flows that I showed early on, right? It just so happens that, that they're a little bit more difficult, I would say, to visually inspect when it's the internal one on the loopback. And I want to point out too, just to kind of reiterate that if I have these windows lined up a little nicer, I can go from, I can inspect the content of each of these, right? So in this window, I can say, oh, I want to see the invite and look at the headers in the invite, right? So I've got my to and from and the via headers, the contact headers like we discussed, and all of these other related headers. In the same way, a trying has its own headers, okay? And so it's going to have the same sort of to and from and via, etc. And authentication, they all have headers, as you can see on the left-hand side panel, if you will, all right? So we mentioned earlier, you can see things like what's going on with a call, right? And who sent a buy. So we'll take this call as an example, and I can see that there's an arrow 172 out to the 208 IP address. I know that our user sent a buy. Well, let me put it this way. Better yet, I know that my PBX sent a buy to the 208 address. So let's just think about, okay, why did the PBX send out a buy to the 208 address? Did the user hang up off of the phone, or why exactly was that buy sent? So let's just take a look at the other leg. So what happened on the A leg side to make the buy be sent on the B leg side? That's what I'd like to inspect now. So, oops, maybe I'll leave the PCAP open. That would be helpful. And I'll go back to this A leg, and I'm going to flow the sequence on this A leg. So what I'm interested now is where the buy originated from originally, right? So I see over here that a buy came from 6050 to, from 6050 to 5060. So in this call, I know that the PBX sent a buy to, the call weaver sent a buy to Camilio. I think I probably have the separate, the other PCAP open, but that's the point I was trying to make, is just that you can go back to the other leg of the call and see, what happened relative to where did the first buy ultimately occur. So you can do that. To me, I like to just, pull up both at one time, flow them both. Now I can look down the column and I can say, okay, what's the first buy sent from anywhere? And it's right there. Okay. So I know in this case, it was Call Weaver sending a buy to Camilio. So presumably, because I can't see the leg of the call to and from the phone, more than likely, the user at the phone itself hung up the call, and then we see a subsequent buy between the two processes, if you will. Okay, so that's kind of what I had to cover. Are there questions about that? No questions. Must be simple. Must be simple stuff. It's I guess I'll wrap then by just saying that ultimately, although it looks somewhat complicated at times, if you really keep that basic call flow in your head at all times, that it's just the same flow done over and over and over on each leg of the call, it becomes much easier to kind of block, block and tackle in your mind, if you will. So, that's it. That's SIP overview in a nutshell, I guess. Kirsten, anything else? All right. Thanks.
Sorry, it didn't help. I was on mute. There is a question.
Oh, okay.
Someone just said one question and then hasn't asked it yet.
Oh, gotcha.
And somebody is asking about registration failures.
Registration failures. So let's just talk about a registration in general, right? So we'll get our sample of what a registration looks like, and it is here, right? So the registration on the left, if I do a PCAP, I generate a trace while I bring a phone online, I can see this registration attempt occur. And when I see it occur, then I can, I'm going to see a 401 unauthorized. I'll likely get a second registration attempt, and that will probably also be a 401 unauthorized because of things like, I don't know, password mismatches or things along those lines. So you can see, instead of a 200 OK, you would end up, seeing something that is like another 401 unauthorized. That's what you would typically see in a PCAP for a failed registration. Hopefully
Um,
that.
and maybe you answered this. It says, can we see registration failure with a SIP carrier?
Sure, absolutely. Just generate a trace. Like what we do quite often is we'll go in WMS, we'll go to the SIP trunk settings, and if it's a registered trunk, then I'll click the button to unregister it. In other words, tell it to not attempt to register, then go start a SIP trace, and then go click change the config on the SIP trunk again to say it's a registered trunk. That way I know that it's going to immediately try to re-register, and I can get it in the trace. And then exactly like I've done here, I'm going to have a trace. I'm going to go to that trace, open it up, and I'm going to see what happens when I sent him a register, what he sent back, what I sent again as a register, the whole flow you'll see.
All right. And then one last one says, are there any other terminations besides a 200, or is it always going to be a 200 to end a call in the PCAP?
No, this is a great question actually. So it's actually quite common to have other things occur other than that. I'll give you a very specific example that would be quite often seen or used on our PBX. If you bring a call in and you route that call to a call group, well, if I have call all 10 as my call group strategy as an example, what happens is that that gets forked, okay? So you'll see one invite coming in, and then you'll see immediately, say, 4 or 5 invites going out, presuming I have 4 or 5 people in the call group. So that A leg call has now been forked and became 4 B leg calls that are all happening simultaneously. So what happens now is when the first of those returns a 200 OK, then all of the other legs of that call will be canceled. Okay. So in a case like that, it was never answered, so I don't get a 200 OK in response to the invite. I instead canceled it, and I'll get a different type of signaling occur in that case. Be careful, by the way, that if you see a 200 OK, that you don't just assume that that 200 OK is related to an invite. So let me just, I'll pull one of these up again. I thought I would pull one of these up again. Seems Wireshark's giving me a problem. Oh, still running somehow. Okay. Okay, so again, I'm going to go to VoIP calls. I'm going to look at, my call flow. And my point is like something like, I'm not sure I have a good example. Yeah, this is a good example of it. Somebody sent a buy, and I've sent a 200 OK. Well, this 200 OK is not for an answer. It's rather in acknowledgement of the buy. Okay, so I can see that in the SIP headers if I go here and look at this guy, right? So it is a buy, or it is a 200 OK, but it is a 200 OK that's related to the buy. Okay, so that's actually, I'm glad you asked the question, because it's a very important point. So this 200 OK, right? It's a 200 OK, but it is in response to an invite. Okay, so it's an important point. Other cases where I wouldn't see something like a 200 OK as a normal response is if my call gets declined. And we actually looked at one of those here. with the echo test. I'm sorry, it was not the echo test. Oh, I remember. It was the one that we did originally. So let's go back to that one real quick because it's a great question. So here, I'm going to make this phone call and I'm going to grab a new trace. I probably have it into my downloads, but I'll try to just do it from here real quick. Oops. Where is my, there we go. So we'll start a trace. And we'll do this call where we call some nonsense, right? Clearly that did not get answered. So for sure, we would not expect to see a 200 OK in response to the invite. So since we've grabbed the trace, we'll download it, we'll take a look at it and kind of prove that to be the case, all right? So telephony VoIP calls, here's my call. And in this case, I sent an invite, they sent a trying, but then they did not send a 200 OK. Instead, they sent a 603 declined, basically saying, I can't route that call, and it's the end of the sequence, other than me acknowledging the fact that they declined the call. So it's a great question. Glad you brought it up. Any other questions?
Nope, that's it.
All right.
All right, thank you.
Great. Thanks, guys. We will talk again soon.
All right, thanks. And as always, this is recorded and I'll be sending out copies for everyone to view later if they need it.
Okay. Bye-bye.
All right, goodbye.